Hello and welcome to this RealFlow 2013 presentation. For technical reasons, we had to re-record this tech preview that we gave a couple of months ago in London. It's taken us a while because we, as you may imagine, are quite busy, but here we go. HyFLIP 2 is by all means the main feature of this RealFlow 2013 upcoming version. It comes with two main changes with respect to the previous version. The main one is that we are adopting a flip solver and we call it HyFLIP, and this is very important because all the bounciness that we got in the previous versions of the hybrid solvers disappears with the implementation of this flip solver, and it also means that the simulations are going to be running way faster and will allow way more particles. The reason for them running faster is because with the flip solver or the flip implementation we can go as low as 1 substep per frame in most of the simulations. Depending on the type of animation that your characters may have if they interact with the water, then you will need to increase the substeps, and that by definition will increase the simulation times, but normally they will run pretty fast with just 1 substep per frame. And we are also adding new solvers to the secondary elements. The bottleneck in the previous hybrid was on the secondary elements spawn. They were SPH, pure SPH from the old implementation that we had in RealFlow, and now we are re-implementing those to accommodate for this hybrid 2. There is also an important aspect of this hybrid 2, and that is that we are going to be keeping pretty much the same workflow, so you won't have to learn how to do these things again. They will be done in pretty much the same way as you were used to if you were using hybrid from their first implementations. You may have seen most of these videos already, but they keep showing how good in terms of detail this new solver is going to be, and also how big can we go in terms of particle counts. We have run some simulations in the office that are going over 400 million particles these days, so prepare your hard drives. These simulations show complex animations interacting with the new solvers. It's pretty solid, pretty stable. As I was saying, you get quite a lot of detail in every single heat of the water with the geometry. It's pretty nice. So we can go crazy with the number of particles now. This one ended up with over 100 million in the end, like 126 million at the very last frame. And if you check the specs on these machines that we were running these tests, they are not extremely crazy. I mean, this is just i7 machines, normal ones, 12 gigs of RAM. Skip a couple of these, show newer ones like that one, this one for example, that we're going to be showing later on. The meshing of this, the level of detail that you get now with the solver is pretty amazing, and simulation times aren't that high. You can run overnight simulations. So how is this going to be looking inside RealFlow? Well, that one with the funds that had 126 millions will be as simple as this. The grid domain will get linked to the grid fluidometer, collide with this group of geometry objects, and also with the outside container. That is probably one of the small changes that we will need to have, because since now we have a sparse grid, we don't have a domain fixed grid. You will need to place a container surrounding where all the simulation is going to be, and then we just linked the forces attached to the solver. So it's pretty straightforward. No major changes, and in the parameters you will see minor modifications, but nothing crazy. To Many people, HyFLIP 2 is the main feature on 2013. For us, RealFlow graphs or the adoption of nodal systems inside RealFlow is as important as this new HyFLIP will be. We are implementing nodes or graphs at two different levels. One is just to create the scene setup, and the other one is to create some sort of visual programming in two different ways, via the batch graphs, which will be similar to what we had with Python scripting, like batch scripting, and also in the simulation graphs, which will run during simulation. So just to show you what we mean by adding graphs in to RealFlow, let's think of how did we do things until now. This is RealFlow 2012, and if we wanted to do something really simple, like creating some basic emission from a particle emitter, adding some forces, making it collide with a plane, and perhaps even adding a mesh. If we hit simulate, with just a few clicks, we get something running. So it's pretty simple, straightforward, and what we don't want to do is to overcomplicate things. We saw here that everything went to the global links, which in theory isn't the most effective way of doing things, so we could have got the same result by using exclusive links, which is a neater way of working. So if we hit simulate, exactly the same result. So why do we go to all the fuss of creating graphs in the first place? Well, this way of working with global and exclusive links is okay, but it allows us to do things like this, which doesn't make sense. And we did have quite a few of those misunderstandings that make people confused sometimes. So if we move to 2013, so you're now gonna see what 2013 is gonna look like, and we go inside RealFlow, you see that for starters we don't have exclusive and global links, but a relationship editor. From here we can either keep using the shelves on top, but we see instantly that we create nodes. So we have our particle emitter, we have our gravity, and we can keep adding things via the shelf, or we can also hit the tab key. They are not getting connected right now as they were in the previous version, because I don't have this add to default hub, which kind of mimics the global links selected. If I do it and I create now the plane, it will get connected to a hub, and if I link everything to that hub, then if I hit simulate, we get the same result as we were getting in 2012. So it's pretty basic still, nothing complicated, and we could see what's going on here if we right click and do view show implicit connection. So it shows that the gravity is connected to the circle, so it's a plane. If we get rid of the hub and we want to connect this like if we were doing it exclusively, what we do is we just drag the plane and the circle, and that's it. So if we reset, simulate, that's the effect. So we haven't changed anything, we are not complicating. If anything, we simplify things by adding these nodes in the form of relationships to generate the scene setups. With the right click here, we can also see some other stuff like a spreadsheet that now allows us, not in this simple scene, but if you have complex scenes, we can select the whole row and disconnect things, connect things at once, etc. So it's gonna be really handy to have this here. If we group things, because we have multiple elements, they will get connected once and then we just connect them. We cannot do it like that right now because it won't allow us to connect things that are not supposed to be connected. That's the good thing of having the nodes, that if a connection is not possible, it won't allow us to connect it. But this is just the basic part of the graph additions inside RealFlow 2013. The real power of using graphs inside RealFlow is in the visual programming graphs through batch or simulation graphs. So if we just simply load a different layout so it accommodates better this area here, we see that now we had the batch graphs, I was saying, which were similar to the batch scripts, and we also have the simulation flow, which changes the name and add the graphs into the simulation events window. So this is simulation flow, and in here we can place graphs networks at any step during the simulation in the same way that we were able to do with Python scripts or C++ plugins. So if we do a very simple example, like for instance, we can get this object and say, right, we want to emit particles as it moves. Let's play with the frames. Let's say from here you will go to here, and you just do a nice rotation or whatever, and just move it up a bit so it does spin a bit, right? So it is gonna be doing that, and while it does that, we want it to be emitting particles from its vertices. If we wanted to do that in previous versions, we will go most likely with scripting, trying to find out the vertices of the object, querying the velocities, and outputting particles from there. This is essentially what we're going to be doing here, but instead of doing it via Python scripting, we're going to be adding a graph. So if we hit the tab key, we can see that there are tons of node graphs at our disposal, and from there we can get something like this get object. We get the object and we put the name of the object cross 01, and for that object we wanted to query its mesh, so we say we want the mesh, get mesh. So we get the mesh and we link the two of them together. If we right click over any of the pins, we get information of the type of the inputs or outputs, what is connected to them. From that mesh we want to get the vertices, so we want the vertices, get vertices, so we will get the array of vertices in here. So it's array, it's a polymorphic, and from those vertices we will have everything we need pretty much. We will have the position of the vertices and the velocities of the geometry vertices. So we just get a channel, so you know that there is a vertex channel that has that information, and we just simply Ctrl+C, Ctrl+V and duplicate that. The channels that are available are here in a drop-down list, so we have the world position, velocity, world normal and index, and also the local position. We're gonna get world position and world velocity. So what's left? What's left is connecting this and adding this to an emitter. So we simply create a container emitter in the scene, copy its name, and we add it here via the get standard emitter. So we get standard emitter and paste the name. So now we just need to add the particles. So we add particle. So as you see, it's very intuitive. When you start typing something, it will show you the options. And we add the emitter, we add the position, the velocities, and if you see here, zoom in, you have the evaluate. This means that we reached the end of the chain, and what it's asking for is an evaluator node. So it knows that now the chain is finished, and it's going to be evaluating all these. So if we save it, and maybe we just change, for the sake of speed, the type of particles to down, and we hit simulate, what we should see is that from the vertices it's going to be emitting particles, and here it is. So we get sun emission from those vertices. Nothing fancy, but tricky to do if we didn't have these tools, and if we had to implement it via Python scripting, we'll need to know the name of the function, so we'll be querying tons of things that is pretty much for free now with the nodal system. From here, we could imagine this was a very, very complex network. We could encapsulate simply right-clicking, saying create compound, and yep, it's a single node. We could output the pins for inputs and outputs that we want to see or we want to expose to, for example, another artist that we want to share this with. We can even export it as XML or import it. So it's gonna be pretty handy to have this around, and it will create a community. We will try on release to have a nice bunch of this at a very high level, so you don't need to create large networks, but we will provide a few of them with complex examples so you can play with them and learn how to use them. With the addition of HyFLIP 2, it was clear that we needed to work on new meshing algorithms, but this isn't only the improvement that we're making to RenderKit 2013. We will also be adding an isotropy measure to the RenderKit 1. So now you will have two options, the isotropic and the anisotropic. And this will give us like thinner meshes. You can see here that kind of get closer to the actual particle representations. On the hybrid 2 meshing, we can clearly see that the advantages of these new meshing algorithms are very powerful, and you see that we keep the detail areas and also the flat surfaces, something that wasn't possible with the previous meshing algorithms that we had in 2012 and before. With the addition of Maxwell Render, we are going to be gaining a very important aspect when doing previews, and that is that now we will be able to send the previews to the farm. So you will have background previews in your farm, something that wasn't possible when we were doing just simple OpenGL previsualization. But not only that, Maxwell Render gives you the best quality rendered in the market. There are over 4,000 materials ready for you to pick up from the online material gallery that Maxwell hosts. And the way that we implement that inside RealFlow is by adding also some fluid material presets like blood, honey, beer, water, etc. And we have the Maxwell interactive render engine Fire. So let me show you that, how it works. In the interface of RealFlow, we have the Maxwell tab, Maxwell button here, where we can set up the scene preferences, very simple stuff, where you just set up the physical sky, or we can set up some panels to add some lights. We can decide how dark the day is and the intensity, the quality of the pre-visualization, number of threads that are going to be used, and pretty much that's it. Global scale is a factor that will help when you're working with attenuation of the light through your materials. But this comes clearer if we simply create a mesh from this particle simulation. Every single object inside RealFlow has now a Maxwell Render tab, and we set up there the materials like honey, blood, as I was saying, milk, water, etc. Let's leave it like honey, for example. Just split this up, which might show it better than putting a floating panel. And it goes Maxwell Interactive, and in a few seconds we get to see the beauty of this render, and we can orbit around and show it to our supervisor or our clients without having to hand over the simulation to the 3D artist that is in charge of lighting, etc. So this is definitely gonna speed up the pipeline between the RealFlow artist and the final lighting or comp artist. this is just like a basic pouring water, etc. But we can also show you an example of what Maxwell gives you with another scene. If I was using a real wave, for instance, now we can instance those planes like along the infinite and create an ocean with just a single tile. We say the number of tiles that we want to tile from there, and we apply the real wave material. Just for the sake of showing you how this changes, let's go to Maxwell Interactive. So this is a plain material in Maxwell, the base one. Call it Lambert if you want in Maxwell, it's like the default material. We want to change it now. Let's just move that and change it to ocean. And I have put the plane at the bottom, so it's gonna cast the real look. And now in a few clicks, you have the look of an ocean that is set to the infinite. So this is just for free, and you see that there is a reflections of this rocket. So we believe that Maxwell is the way forward for rendering, so having it inside RealFlow is a big plus for all RealFlow users. We have finally decided to make Alembic integration inside RealFlow, and Alembic format will become one of the most important ones, not only for geometry but also for particle interchange. This will become very important when talking Hybrid 2 because the file caches will be massive, and we will adopt Alembic as the main format for the base of the simulation together with Field 3D. Inside RealFlow, we will have, for pretty much anything that we can export, if we go to Export Central, we'll see that there is an Alembic sequence export for particles where we can decide which magnitudes we want to export, and this will definitely reduce the size of the files quite a lot once we start just deciding which ones we need. Same for Hybrido, as I was saying, the GDC file format will get deprecated, so we will only have Alembic caches and some of the others together with Field 3D. For objects, we will have Alembic animations, and the same will be set for meshes, where we have mesh sequences as ABCs. And here we have the Alembic compression hints, so we can decide which level of compressions do we want for the Alembic format. We will also be having some tools to stitch together Alembic files, so we will be able to decide to stitch just a range of the whole simulation. If we need to, if we're going to be using Alembic individual files, it's fine, but if we want to put together the whole simulation, then we may end up with huge file sizes, so we can decide which range do we want to stitch together, and that probably will go under tools somewhere here, or we will also have a command line operation tool. Very important, thanks to Alembic, and let's remove this, is that now the SD format, the proprietary format that we had, will kind of get deprecated as well, mainly because there were tons of things that we couldn't do with it, and thanks to Alembic they will be possible now. If I import, for example, this Alembic file that has multiple pieces and a nice animation, we now can, for instance, say, okay, this is only the area that is going to be collided with my fluid, so I can get rid of all this, and it still remains animation, and I can do undo if I needed to, because I failed or I deleted something I didn't want to, and still works, something that didn't work with the SD format that we had. We can even do Control D and duplicate, and even put in different position parts of that animation, and it still works. So it's tons of improvement and additions thanks to Alembic will make our SD format pretty much a thing of the past. Viewport Plus is what we like to call the enhancement that we have put into the RealFlow GUI. In previous versions it was very difficult to move around when you had quite a few millions of particles. This is gone now, and as you may see right here, we are not able to handle massive amount of data without penalizing that much user experience. Like here we have 31 million particles and we can still move around quite easily, and it's quite a lot of detail in this simulation. Some other enhancement that we have put there is, like, for example, if you go to the display tab on the grid domain, you will find that there is a particle percentage, and now if we go, for example, to 50%, instantly you see that there has been a decrease and things will move slightly faster. We can still go down to 10%. We don't lose the look and feel, so we can still work with that. And we can go as low as 1%, and this is pretty much bounding box displaying those 31 plus million particles. I think it's a pretty cool enhancement, and it will make life way easier when dealing with big amounts of particles. On the RealFlow body dynamics side of things, we have decided not to add many features on this release, but to improve what there was already there. The body dynamic solver will be faster and more stable, especially when dealing with multi-joints. And the area in which we have added some new features is in the fracturing. So if we go to RealFlow, any object inside RealFlow, this is not, by all means, this is not the final look of the interface, but you will get to decide among multiple ways of fracturing. Now, previous version there was only the uniform boronoid. Now we have the ability to fracture by geometry, by points, or create radial patterns. Some examples of that are here. Well, this is an example that includes pretty much all different methods. The coloring is just in the framework that we're using before integrating this inside RealFlow, and the coloring means that the object has energy or not. So this is part of the speed improvements. When an object is red, it has full energy, it's losing energy, changes color until it gets to white, which means that it doesn't have any energy left. If an object is with no energy and another object touches it, then it comes back into the solver and again goes into the dynamic. As you see, these simulations are pretty stable. You don't get to see jittering on the objects in the floor, and the multi-joints are way better in this version. Last but not least, we are also adding a feature to the licensing, and this is not other than the ability to move the GUI license to the license manager. So all the licenses within the RealFlow pipeline, the RealFlow GUI, the RealFlow nodes, and the RealFlow render kits can be hosted under the same umbrella on the Next Limit license manager. This will be the way that it will be on release, and probably in the near future we'll move to a standard commercial package for licensing. And that's all for me. Thank you very much for watching, and keep it real.